Hi there. Now we are going to train a model on famous iris dataset that contain four columns of features which contain information about a flower. You can download the dataset from the link I have provided in the lecture. Now let me show you the dataset. This is the dataset you will get after downloading from that link. It consists of total five columns, which is petal length, petal width, sepal length, sepal width, and at the end we have the flower category from which category it belongs. It is having three categories, which is setosa, and down there we have versicolor, and here we have virginica. So there are three categories of flower, and like this is a classification problem because we know the predictions already. Like predictions lie within these three categories. Now, what are the this petal and sepal? Well, if you have studied bio, then you may know this, but I have this image. The petal is the original this leaf of flower. Any flower you have, and the leaf will be known as petal. And this leaf, which is like covering of the flower, it is known as sepal. Okay, I don't know the right pronunciation, but I hope you got the idea from this image. So these are the things we are having. Petal length, what is the length of petal, petal width, what is the width of petal, sepal length, sepal width, and then so on. This dataset have 150 data points, like it contain information of 150 flowers. Now seeing the this data point, we get that the petal length is 4.6, the petal width is 3.4, the sepal length is 1.4, and width is 0.2, 0.3, and the category of flower is setosa, and so on. I will show you to the end. It is having 150 data points. So now 151 data points. So now we have a good data to train our model. Here we are loading the dataset and doing all the pre-processing needed. In the very first cell, like import pandas as PD, we are importing the pandas module of Python so that we can load the dataset. In this second line of code, we have the path of dataset. Like you can have any different path. For my case, I had a folder datasets within my local disk D, and within that I had iris.csv file in which there is my data. So you will also have a CSV file. So this is the way how you load a CSV data frame. After this head to show the top five columns of our data. Here I am checking the shape. What is the shape of our mode of our data? And it is 150 and 150 rows and five columns. So five columns, as we discussed, four of them are feature, and the last one, which is flower, it is going to be our label, because this is what we are going to predict later on. And the first four columns are the features. Now in this line of code, we are importing the model that we want, and that is Kneighbors classifier. And in the very next cell, again, now we are specifying the features and labels, and it the same way we were doing in previous lectures. Within the square brackets, double square brackets, we had column names, and features are first four columns as I have shown here, and label is the last column which is named flower. In this line of code 16, I have initialized the model so that we can train that model later on. Here dot fit, what it will do, it will train the model. And features, the first argument is features and the second argument is the label. And if you have created different variables like x and y, so you will pass x instead of features and y instead of labels. All done for this model. It is trained. Now we can make prediction. And to make prediction, we have to give features to our model. And I have given these features as, let's say, the petal length is 2, petal width is 3, sepal length is 1, and sepal width is 2. With the arrangement as we had column names, I have given the data points. And after running this, we have our prediction. Our model think it is a setosa. So it is a species of flower, setosa. So our model think that flower with these features is can be setosa, and it can be wrong. We will discuss how to calculate the accuracy in the later lectures.